The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Our next speaker is Stephen Scalco. Stephen is somebody that I've worked with. I'm very fortunate to work with a lot of very smart folks, and Stephen is one of those folks. He's the manager of regional codes and standards with the Portland Cement Association. Steve graduated with a Bachelor of Civil Engineering degree at Georgia Institute of Technology. He has his Master's of Science in Administration degree from Georgia College and State University. Steve is a registered professional engineer in the state of Georgia. He has been involved with codes and standards for almost 30 years, first as a building official and fire marshal for a local government jurisdiction, and now as a representative of the Portland Cement Association. He participates in codes and standards development through the International Code Council, the ICC, the National Fire Protection Association, and NFPA, the American Society of Heating, Refrigeration, and Air Conditioning, ASHRAE, left out engineers, sorry, the American Society of Civil Engineers, and the American Society for Testing and Materials. As a former code official, he has served on the CABO 1 and 2 family dwelling codes, OTFDC, and the Model Energy Code, MEC. He has also served on the International Energy Conservation Code, the IECC committee. He's involved with ASHRAE. His involvement with ASHRAE includes serving on the Standing Standard Project Committees, the SSPC, responsible for the development of ASHRAE 90.1 and 90.2, which are the energy standard for buildings except for low-rise residential, and the energy efficient design and low-rise residential buildings. He is presently chair of the project committee responsible for ASHRAE 90.1, and he's previously served as vice chair of the 90.1 committee. He has also held the position of envelope subcommittee chair, and he is past chair of the full committee and envelope subcommittee for 90.2, low-rise residential standard. Please help me welcome Stephen to the podium.
Well, I tell you what, that was a lot of acronyms I had in my introduction. I didn't realize I had quite so many. But anyways, I'm glad to be here this morning, or this afternoon, and to be able to present to y'all the thermal mass provisions that are in ASHRAE Standard 90.1 and the International Energy Conservation Code. The objectives that I hope to accomplish today in doing this thing is, one, I think it's important, just like what Dr. Haberl just showed us, that we have to kind of review about the history of the development of ASHRAE Standard 90.1 and the formerly Model Energy Code, which is now called the International Energy Conservation Code. And part of that is because when you go through the history, you can see how things changed over time for there to be thermal mass provisions introduced into the code, and some of the evolving that actually took place with those provisions to end up with the result of what we have today. The other thing I want to look at is looking at both of the documents. Look at the format that was used and that is used for the prescriptive provisions. The format sometimes can make a difference in that it's there for the purpose of teaching the designer how to make use of it, to simplify it enough so that they in fact can apply it. Sometimes that does create some of the difficulties, especially for the architects when they perhaps want to give consideration to using thermal mass provisions. and trying to understand how can they make use of that, short of going through the process of doing sophisticated modeling, which in today's time is becoming more important, and you'll see with our presenters that will be following me after I present mine. And then finally, the last thing is I'm going to show actually the entries into some of the tables and let you see the impact that thermal mass actually shows up. So let me start with this timeline that I've placed up here, rather simple in nature. It shows 1975, and I'll kind of ask for the audience to real quick, what was happening in the early 70s in our country that made energy conservation such an important issue? Oil embargo, sure enough. And of course, as a part of that, we began to become energy conscious about our buildings, and from that, there was a lot of interest to say, well, how can we come up with something that we can put out there into the marketplace that designers could be able to use? And one of the organizations that was approached was the American Society of Heating, Refrigeration, and Air Conditioning Engineers, for them to see if they can't start putting together some information. There was some early efforts done by the federal government in looking at coming up with standards and requirements, but I think it finally made it realize that let's put it out into the public process through consensus, and ASHRAE became the organization that was chosen to do that. I want to tell you something of interest. On my way flying here yesterday from Georgia, I was reading in my newspaper a bit of history, and believe it or not, yesterday, but in 1974, yesterday was the day that most of the OPEC nations actually took a vote to try to remove or lift some of the embargo provisions that they had placed on the United States at that time. So it's kind of interesting to have that time point in history happening about the time that our presentations are taking place today. So 1975 became important. ASHRAE, in developing this standard, basically we're having to develop it based on best practices. And to a large extent, though I haven't compared it, it would not surprise me that much of those best practices are some of the very same things that were the things you were seeing presented in the previous presentation. They reflected what the industry knew at the time. They reflected what we knew how to do. And in some way try to put it into something that could be utilized out in the marketplace, in this case the standard, to be used by the designers so that there would be some kind of standardization of what we do. The other thing that's important about that 1975, though, is there was also a realization that we can come up with a standard, we can have it out there, we can have designers consider using it, but the reality is unless it can be applied and in some cases enforced, meaning adoptable, then really the standard maybe won't take us anywhere. And so there was an effort put together by model code groups at that time to form an organization called the Council of American Building Officials. That's what CABO stands for, that Larry Rowland did my introduction. And they produced the first model energy code in 1977. It was basically the provisions that were in ASHRAE Standard 9075. And of course, one of the things they did for the building envelope, which is the primary area of concern for the prescriptive thermal mass provisions, is to look at thermal transmittance through the walls. And by doing that, what they did was come up with standard criteria that would tell you what your thermal transmittance should be for roofs, for walls, for floors, for windows, and for skylights. And from that, we would define what kind of energy transmission we would allow, or thermal transmittance we would allow through the envelope of the building. And of course, one of the things to always keep in mind when we talk about U values, or in essence thermal transmittance, the smaller the value, the better it is from an energy conservation point of view. Here's what the graph looked like for applying it for residential construction in the model energy code of that time. The A1 were 1 and 2 family dwellings. The A2 buildings were basically multi-story up to 3 stories, multi-family buildings. You would basically enter the bottom of the chart based on where the heating degree days were for the location where you were building. You would go up in a vertical manner till you reach the line of which type of building you were building, and then you would transfer it back across to the left in order to choose what your U factor should be for your building envelope. This is what the one for the commercial buildings look like. Very similar in nature in terms of how it's structured, but in this case you are actually coming up with the value, what they actually refer to as an overall thermal transfer value. I'm showing just the graph for walls. They in essence had graphs for the slabs, and they also had grass for the roofs. But regardless, they did make a distinction between commercial buildings and residential buildings. The timeline then continues in 1980. ASHRAE took a step farther and actually separated out their documents for commercial and residential into two separate documents. Hence why you heard in the introduction of my background, ASHRAE Standard 90.2 is for low-rise residential. ASHRAE Standard 90.1 is for all commercial buildings except or actually all buildings except low-rise residential. And that's where they started to make a distinction in those two categories of buildings. The Model Energy Code continued to develop along that time by incorporating many of the things that were happening within the ASHRAE consensus process. And many times it was putting it into a codified form that city and state jurisdictions and county jurisdictions could adopt and enforce. Another very important point, though, was all the time up to that point, everything was stated in U values. And it was really hard to really come upon how to incorporate taking advantage of thermal mass provisions. But the mass industry, which included the concrete industry, the masonry industry, and the wood industry through heavy timber, which is a mass material, got together and through a process of things that each had been doing, some research and modeling based on the available techniques at that time, started coming up with some values to show how we could accommodate the use of mass in the provisions that would acknowledge and recognize that there are benefits to it. And when the mass industries came together at that time, they submitted code changes to the Model Energy Code, and those code changes through the code change process got incorporated in the 1988 addendum to the Model Energy Code. And of course, what we're talking about is simply the fact that you can take energy, heat up your heavy mass materials, and it stores more energy, or you can take a lightweight envelope, and it takes a lot more energy to heat the building, but you don't get as much energy stored within the structure itself. And of course, the table was rather simple that was devised at that time. This is the table out of the 1988 Model Energy Code. You entered the table on the left-hand column, which was heating degree days, and at that point, wherever you were in the heating degree days, you would go across the table with the top row showing you what the U value was for a light frame wall. And once you knew what your U value was required to be for a light frame wall, if you will look at any one of the numbers in the columns, you will see that the number goes up for a mass wall. So I'll take the very first entry, 0 to 2,000, and you look at the second column from the left at 0.24 for a lightweight wall. You will see for 0 to 2,000, my U value for a mass wall is 0.33. Keeping in mind 0.33 means that it has a lesser degree of a higher degree of thermal transmittance through the wall, but the fact is it's recognizing the thermal mass that's in the wall. So that table allowed us the ability to recognize thermal mass, but it's still not as user-friendly at the time since we're having to deal with U factors. And of course, the next thing that happened that was very major from that, and I'm sorry, let me back up and mention this, that particular application initially submitted was only for residential construction. It only applied for low-rise residential and 1- and 2-family dwellings. So the next major thing that happened is through the work of the mass industries is to get things incorporated into ASHRAE Standard 189, that being the standard for commercial buildings at that time. And of course what they ended up doing was introducing tables that would recognize thermal mass as part of the requirements for wall construction depending on your location. Now there's a lot of complexity to the table, but I want to point out two things very quickly. You'll notice where my arrow points, that is the box that would tell you what you have to do for lightweight walls. The next box is the box that would tell you what you have to do for mass walls. It might look a little bit more complex, and it was in many regards, because it did acknowledge the fact that you got benefits for thermal mass, but you had to go through a few more hoops to apply it. It included the fact that you had to look at how much your internal load was going to be from the design point of view, whether it be from people and furniture or lighting. You had 3 different categories of internal load range that you would look at, and depending on what the designer chose, that's how you would start to determine what my envelope provisions would be. You'd look at fenestration, fenestration being windows and skylights. How much fenestration is being used would have an impact on the range of the mass wall. You would look at the heat capacity of the wall, just how much heat capacity you had, that you had 3 different ranges that you could apply in terms of each of those fenestration choices. And then from that, you would also decide, well, would I have insulation on the interior of the building or the exterior of the building? Because that made a difference in what the value would be. The important thing is, though, thermal mass was being recognized in the commercial code and readily available. A little cumbersome to use, but still it was there, and it was based on much of the modeling that was used to first introduce it. As we look at the timeline and continue, we'll find that there was very little change for prescriptive requirements in the Model Energy Code or in ASHRAE Standard 189 until 1999, and at that time there were major revisions to the building envelope. The major revisions that took place was to simplify the table for applying it. The simplification, and you can't realize you can't see this table, but I'm going to concentrate on just this part. You will see that the two biggest simplifications were that it introduced that you told somebody what the assembly's U factor had to be for a particular assembly, or you could apply simply an insulation value, that it would be the effective insulation that you installed in the wall. And that made it much simpler for the designers. The other significant thing that happened is we also started distinguishing between mass roofs, mass walls, walls below grade, mass floors, and these would be floors over unheated or outside temperatures. And of course, the last one I didn't do it, but there's also slabs on grade. But the important part was in doing that, it told how to simply apply mass provisions and apply R values to them and make it readily available just based on the climate zone. The last major change, excuse me, before I get to the last major change, I wanted to comment the 2000 IEC, in 2000, the Model Energy Code transferred to become the International Energy Conservation Code and continue this continuity by incorporating the provisions that you see in the 1999 standard. They did that in between 2000 and 2004. In 2004, the other major change was we changed the climate maps, climate data we used from 26 different tables to 8 tables, and went to a simplified prescriptive map, and that made it easier for the application of those provisions. I want to tell you that the 2004 IECC followed track with ASHRAE and incorporated the climate data. And of course, when you go to look today, we're up to 2010. There is a 2013 edition of the IECC that my committee now will be responsible for producing. But I want to just focus for a minute on 2010. That is also what through the 2009 IECC, it's based on the same document. It uses a similar table. It shows based on a climate zone, insulation entirely above deck. There are the values to apply. There's a mass wall. There are the values to apply. There is a below grade wall. There is a values to apply, no requirements. And I should tell you, climate zone 3, I chose it because that's Dallas, Texas. Mass wall, the values, and then unheated spaces. And if you go to looking at the IECC, their table's a little bit different. There's climate zone 3, but you will see they have the same values that we apply when we do the 90.1 standard. And so I do want to comment that they put a separate table in there for low-rise residential, also following mass walls and basement walls and slabs, kept it simple. My comment to you is that the simplified provisions are easy to use, but they really don't take advantage, I think, of thermal mass like we can if we go into the modeling aspects, which is what I think the next part of our seminar will be.
Well, thank you very much, Steve. We do have time for one question or possibly two. Is there anyone who'd like to step up to the podium and give us a question? All right. Thank you.
I have a question. This is Nick Marshall from Morris Michigan. The question, Steve, is are the reductions from thermal mass and codes going away?
Let me respond that the answer is not that they're going away, but there's no doubt the way the codes have been developing in the real recent years is to look for the folks are saying let's put more insulation in, and not acknowledging that you still should be able to take advantage of thermal mass. So we are losing, in essence, the edge of the distinction between a light frame wall and a mass wall, or light frame assemblies and mass assemblies. We're losing the amount of advantage that we had in the previous editions up to the 2010 90.1.